Okay, ladies and gentlemen, this is going to be a video about the Big 20 quiz reviewing. I'm recording it during my 6th period class, which should be quiet right now as I'm recording. Now, I've been asked to go over question number 7 from the Big 20, and that should be the percent of a number type question, where you might be asked something like 5.2% of, let's say, $725. Okay, now, occasionally there will be the units of dollars on these. Sometimes there will, sometimes there won't. There is some things you need to think about when you do have the dollar sign there. You do need to include that dollar sign in your answers. Okay, I have been corrected. This is a number 10 type problem. We'll go over this, and then we'll go over number 7. All right, sorry about that. Number 10, so number 10 with this type of problem, we are going to convert the percent to a decimal. To convert a percent to a decimal, you start by dividing by 100. To divide by 100, you move the decimal 2 places to the left. So this becomes 0.052, and you're going to multiply that decimal version times the number. So we're going to have 725 times 0.052. Okay, multiplying through, I do the 2 times 5, which give me a 10, carry the 1. 2 times 2 is 4, plus 1, and you get 5. 2 times 7 is 14, so that's the top number there. Placeholder 0, 5 times 5 is 25, carry the 2. 5 times 2 is 10, plus 2, I get 12, carry the 1. 5 times 7 is 35, plus 1, I get 36. Add these together, carry the 1. I get 377.00, or 37700. There are 3 decimal places in my multiplying problem, so I need to move my decimal over 3 places. My final answer is 37.7, but since this is dollars, I am going to include that second decimal place of a 0 and put the dollar sign here. That is the final answer. If there were no dollars, if it was just the number, I could get away with just the 37.7. But when you've got the dollar sign, you've got to include the 2 decimal places. Okay, now number 7 is actually the fraction converting to a percent. The first thing to do to get that is you are going to convert the fraction to a decimal. The bottom number goes on the outside of the long division. The top number goes on the inside there. Now, we're going to do 8 goes into 1. It doesn't go into 1 at all. Put a decimal point there. Carry the decimal point up. Put an extra 0 in here. 8 goes into 10 once. Subtract the 8 there. I get 2 left over. Have to keep going because as long as it doesn't repeat or terminate, we have to keep going. Bring down the 0, we get 20. 2 times 8 gives me 16. Gives me a remainder of 4. Another 0, bring that down, I get 40. And 8 times 5 would give me 40, which means I now have a remainder of 0. So at this point, my decimal is 0.125. To convert to a percent, I need to multiply that by 100, which is going to move the decimal point 2 place values to the right. Moving 2 decimal place values to the right is multiplying by 100. So this now becomes 12.5. Don't forget the percent sign. You were asked to convert to a percent. Having the percent sign on there is part of your answer. Okay, numbers 14 and 15 are about adding and subtracting of mixed numbers. Now, a lot of people will handle the whole numbers and the fractions separately, and you're welcome to do that. In some cases, that might work out just fine. There are ways where you can do this. It might be quicker doing it with the whole numbers and fractions separately. But if you're having troubles with this, one of the best ways to avoid simple errors is actually just to convert to improper fractions and work with the improper fractions. So to convert to an improper fraction, I'm going to multiply the whole number by the denominator, the bottom number there, and add it to the top. So 8 times 4 is 32, plus 1 gives me 33. So I have 33 fourths minus 1 times 2 is 2, plus 1 is 3. I have 3 halves. Now from there, you could work with the common denominator, and it's pretty easy to see here the common denominator between these two would be a 4. But if you're having issues with that, you may want to work with the butterfly method. To do the butterfly method, you're going to multiply the two diagonals. You're going to bring this sign up. So whatever the operation, you're going to bring that up. And then you're going to multiply the bottom numbers. Notice how the resulting picture here kind of looks like a butterfly. Not a very good one, but a butterfly nonetheless. All right, 2 times 33 gives me 66. 4 times 3 is 12. 4 times 2 is going to give me an 8. If I can actually get this thing to draw. There's the 8. So this becomes 66 minus 12 over 8. 66 minus 12 is 54 over 8. 8 goes into 54 6 times with 6 left over. The remainder will always go to the top. All right. Now 6/8 can be simplified. They're both even, so you end up getting 6. Oh, sorry, not equal. It's 6 and 3/4. Okay, number 15 is all about multiplying mixed numbers, and 16 is about dividing mixed numbers. If you can do the multiplying of mixed numbers, dividing is really the same because you do the keep it, change it, flip it. So it ends up being a multiplying problem anyway. The first step for either one of them is, with the multiplying, you have to convert to improper fractions. You cannot work with them separately. To work with them separately requires you to not only do the 4 times the 2, but you have to do the 4 times the 3/5. And you have to do the 1/3 times the 2 and the 1/3 times the 3/5, and then add all that together. Not really the way you want to go with this. So what I recommend is that you do convert to improper. 4 times 3 is 12, plus 1 is 13. 2 times 5 is 10, plus 3 is 13, so we get 13 over 5 here. We're still multiplying. When you multiply fractions, it's top times top over bottom times bottom. 13 times 13 is 169. 3 times 5 is 15. Now I could look for a common factor there and reduce. I think there might be a common factor of 3, but I think I'm going to convert to a mixed number first. 15 goes into 150 10 times. So I'm thinking it goes into 169 11 times. So I'm going to have 11 whole numbers. Now if I do 11 times 15, I do get 165, which when I subtract from the 169, if I do 169 minus the 165, I get a remainder of 4. That remainder is going to go over the 15. So I get 11 and 4 over 15. Yeah, 15, like that. Okay? I know my writing's not perfect, but... Now, I made these numbers up. It may not work out to be that great of a decimal. It may end up being some sort of repeating part here. Hopefully it's not. Number 20 is always going to be a dividing with decimals. It should end up being a decimal that does terminate, doesn't go on repeating or anything. It should terminate within like 3 numbers. It shouldn't take you hours to do this. If I have 0.15 here, I'm going to do that. It goes on the outside of the long division. The 12.35 goes on the inside. That number on the inside, that number on the outside. All right, and you can't technically divide by that decimal. So what you do is you need to make that into a whole number by moving the decimal over 2 place values. But if you do that to the outside number, you got to do the same thing to that inside number. Move that decimal over 2 place values. So we end up getting 15 goes into 1, 2, 3, 5. Okay, 15 does not go into 12. It does go into 123. I'm going to say 8 times. 8 times 5 is 40. Carry the 4. I get 120. Ooh, good guess there. Okay, so subtract that from the 123. I get a 3. Bring down the 5. 15 goes into 35 twice, which is a 30. Subtract that, I get a remainder of 5. Now I got to put a decimal in. Bring down the 0. 15 goes into 50 3 times, which is going to give me a 45, which you'll notice now I'm going to end up having a repeating here. So we're talking about this being a repeating decimal. So my answer on this one is 82.3 repeating. Now, hopefully, if I've designed the Big 20 quizzes correctly, they shouldn't be repeating decimals. It should be a terminating decimal for an answer. But this one did work out to be that way, so it did stop, and there we can give our answer like this. I would accept this as an answer. I would accept 82.33, because remember, I would expect at least 2 decimal places. But on the Big 20, generally, you do have to keep going. You can't, unless it definitely repeats, you need to keep going and show me as many decimal places as needed. It may take 3 or 4 decimal places, so you may need to go further on that.